In this video, I'm going to discuss with you VLSM, Variable Length Subnet Mask. This is a networking technique that allows administrators to divide a single IP address space into smaller subnets of different sizes. So we have an example here with this scenario. A company, ABC, owns a block of IP addresses 48.2.3.0/24. The company needs to address three offices as follows. So this is the local area, this is the network of the company, and it connects three offices. Office 1 with 100 user requirement, Office 2 with 50 user requirement, and Office 3 with 20 user requirement. And the company owns this block of IP addresses. So we are going to subnet this so that the requirements will be supported using this block of IP addresses. Okay, the first step is to write the network owns by the company. So this is the network owns by the company. It is with a bit mask of 24. Therefore, the first 24 bits represent the network part. So we have this, and the first three octets are the network bits, while the last octet is for the host bits. So we are going to focus on or to work on the host bits here. So these are the 8 bits, and on top of each of these bits is the place value of 2, this being a binary. So starting from 2 raised to 0, that will be 1, 2 raised to 1 is 2, and so on up to the left. So we have this 1, 2, 4, 8, 16, 32, 64, 1 to 8 corresponding to each of these bits. Okay, so first we arrange the user requirements from highest to lowest. So obviously the highest is 100 users. So we will start supporting the highest host requirement, which is 100 users. So we now compare 100 to the numbers here. And there are 3 criteria we must follow in order to be able to identify which of these numbers is the one we are going to consider. So the first criterion is, okay, the number must be greater than the user requirement. Okay, user requirement. There. Here. And the second criterion is the number must be the one nearest to the number of users. And thirdly, the number must be greater by at least 2. Then. Okay, so let's start with 100 users. First criterion, number must be greater than 100. So which of these numbers is greater than 100? It is only 1, 2, 8. Now, okay, so let me just circle that. This is the only number that is greater than 100 users among all these numbers. So Definitely, this is the one nearest to 100, and this is 18 more than 100, so it is also uh, satisfying this criterion. Therefore, this is now the chosen number, and we now focus on the bit below it, and to its left there's no more bit here, so we'll just be borrowing one bit to be able to support this. We borrow one bit from the host, and this one bit becomes a part of the network. So to support this 100 users, we will now take the first subnet, which is 48.2.3.0 slash, instead of using 24 now, we add the 1 bit here. So 24 plus 1, it is now 25. Okay? So this is the network that we are going to use to support the 100 user requirement for Office 1. And what is the subnet mask of the bit mask 25? So of course, the first octet would still be complete 8, and that will be, if you add all this for a complete 8-bit octet, add all these numbers, this would sum up to 255. Okay, the next octet still complete for network, so that would still be 255. The third octet still complete for network, and for the fourth octet you only have one bit for the network, and that will only be equal to 128. So this is the subnet mask for this subnetwork. Okay, the next subnet after this will be 48. This will be the next subnet, 48.2.3, and we are going to add this number to the host part. So 0 plus 128, that will be 128. Okay, this now we are going to use to support the 50 users. Yeah. But now, here we do not use fixed length subnet mask. Instead, we use varying. So the next thing we do is to compare this number, or to compare this requirement to the numbers here, just like what we did with the 100 users. So 50 users, first criterion, number that is greater than 50, there are two, 128 and 64, right? Now, which of these two is nearest to 50? That's 64. And is 64 greater than 50 by at least 2? Yes, it is greater by 14. Therefore, 64 will be the number for these users. And going down to the bit and count the bits to the left, you have now 2 bits to be added to the original network bits, which is 24. So this will now be 26. Then, and this one has a subnet mask of 255. That 255. That 255. That, since there are 2 bits for the fourth octet that represent the network part, so we will add these 2 numbers, 128 plus 64, that will be 192. Then, so we use this to support the second office. Now, for the third subnet, we now have 48.2.3. What comes next after 128? So, since we have here a bit mass of 26 here, we will add 64 to 128. It is no longer 128 being added here. Instead, the current bit here, which is last 26, so 64 will be added to 128, and that will be 192. Okay, this is now the network that will support 20 users. Okay, and this time, we compare this to these numbers. So again, which of these numbers is greater than user requirement of 20? There are 3. 128, 64, and 32. Now, which of these is nearest to 20? It's 32. Is 32 greater by at least 2 than the user? Yes, it is greater by 12. Therefore, this is now the bit that we will consider for the third subnet. And therefore, from this bit to the left, there are now 3. There are now 3 bits to be added to the network part, 24, and we'll have here slash 27. Okay? And what is the subnet mask for slash 27? That will be 255 for the first 8, that 255 for the second, that 255 for the third, and the fourth, we add these 3, 128 plus 64 plus 32, we get 2, 2, 4. So that is the subnet mask for this subnet. Okay, so what comes next after the third subnet? So the fourth subnet, we now add 32 to the fourth octet. So that will be 48, that 2, that 3, that plus 32, you'll get 2 to 4. Okay, so this we will use for the first office. 48, that 2, that 3, that 0 slash 25. For the second office, we use 48, that 2, that 3, that 128 slash 26. And for the third, we use 48, that 2, that 3, that 192 slash 27. Yeah. Okay. Now, what are the usable IP addresses in this first subnet? So for usable, it should start from 48.2.3.1 up to the second to the last before this next subnet, and that will be 48.2.3.126, because the last IP 48.2.3.127 before 128 is the broadcast address of this network. Okay, so we can use 3.1 up to 3.126 to support the 100 users. For the second subnet, The usable will be from 48.2.3. The first after the network 129 up to the second to the last before 192, and that will be 48.2.3.190. Yeah. And the last one 48.2.3.191. This IP before the next network is the broadcast address for this subnet. So we can use 3.129 up to 3.190 to support the 50 users here. And lastly, for the third subnet, the usable would be from 48.2.3.193 up to the second to the last before 224, 48.2.3.222, because the last IP, which is 48.2.3.223, is the broadcast address of this subnet. Okay, so here we were able to divide this network into different subnetworks that are enough to support the requirements. Okay, let us now try to simulate this, and so that we can check the validity of the procedure that we just take. Okay, so we're using a network simulator, say a packet tracer. Connect these devices as shown. You use 2911 router, you use 2960 switches and generic computers. Connect them using straight through cables, and if you are using a 2911 router, there are 3 immediate Giga Ethernet ports, namely G00, where you will connect the devices in the Office 1. Then next G01 connects to Office 2. Then G02 connects to Office 3. So we now assign IP addresses to the PCs or to these representatives of the offices. So if we do that based on the configuration, this will be the IP addresses then. Okay, so IP configuration of the PCs for PC1. Okay, for PC1, so let me just place it here, there. For the first computer, PC1, its IP address will come from the usable. Okay, this is the space for Office 1. So we will configure it with 48.2.3.2. Okay, the second usable, because the first one, 48.2.3.1, is normally used for the default gateway. Okay, so the IP address of PC1 is, or would come from this space, and that is 48.2.3.2, and the first usable will be the default gateway of all the PCs here, which means that this address must be configured to that interface later. And what will be the subnet mask of this IP address? That will be the subnet mask here. which is 255.255.255.128. Okay? For PC2, this is the address space where PC2 belongs. So its IP address should come from the usable, and that will be the second usable, which is 48.2.3.130. And this first usable will be the default gateway here. Okay, and the subnet mask will be for /26 255.255.255.192. That is for the second PC. And for the third PC, here, there, the space must come from this usable. So we use the second usable after 193, that will be 194. And the 193, which is the first usable, is also the default gateway. And the subnet mask will be the subnet mask for /27. Okay, so after configuring the PCs, we are now ready to configure the router. Again, using the simulator packet tracer. Okay, let's configure. Let's use this space. Okay, so for the router, if you use the command line interface of the router, you will be prompted with this. Let me use space. So for CLI, you will be prompted with the question, do you want to continue with the configuration dialog? You just type no, and then you will have this prompt. The default name of router is router, with this symbol that manifests that you are in the executive mode of the command line interface. So you type EN, which is a shortcut for enable, and when you press return, this symbol changes to £, which means that we are now at the privilege mode. Okay, we are now at the privilege mode. Okay, so the privilege mode, you type config T, which is short for configure terminal, and this now becomes router config, which is an indication that we are at the global mode. At the global mode, whatever command you issue will affect the entire router. So if you want to know which command to you, or the commands that can be used in this mode, just type question mark for help, then press enter, and you will have a list of commands. So we change its host name by typing host, shortcut for host name, then the name of the router, which is ABC, so you type ABC. And as you press enter, the router changes its name to ABC, maintaining the global mode. Then, okay, we now go to the interfaces. Let's go to the first interface, G00, and if we press enter, this now changes to config IF, which is an indication that we are now inside this interface, and whatever command we issue here would affect only the Giga Ethernet 00 port. By default, the interfaces of routers are in shutdown modes. So that's why you can see here in color red, which means that these are not yet physically connected. So how do you change the state of this interface from down to up? You just issue the command no shut, and as you press enter, this one turns to green, indicating that the state of this interface is now up. Okay, then press enter. Okay, and that would still be in the interface mode. And we now issue an IP address here which will serve as the default gateway for all the computers in this Office 1 network. And what is the default gateway that we allot for this network? That is the first usable here, 48.2.3.1. So we type here IP add 192, I'm sorry, 48 there. Let me just erase this because there should be a space. Yeah, there should be a space. So IP add space 48 there, 48 dot 2 dot 3 dot 1. Okay, then space, then the subnet mask. By the way, this is in straight line, okay? Just a space, then the subnet mask 255.255.255.128. Then press enter. Okay, you are still in the interface G00. You now transfer to the next interface. So you type the name of the next interface. Interface space G01. This will now overlap the previous one. So as you press enter, you now shift to the interface G01. Just like what we did here, we issue no shot. Okay, then press enter. This will turn to green, meaning G01 is now in up state. And then we also issue the IP add for this interface, and that is the default gateway of all the PCs here, which is this first usable. So IP add 48 dot 2 dot 3 dot 48.2.3.129. There. 48.2.3. You can no longer see that, so I'll just write it here. .129. There. Again, 48.2.3.129. Then space, then the subnet mask 255.255.192. There, the subnet mask for Office 2. Then we press enter. Then we go to the last interface, which is G02, INT G02. Then just like what we did in the previous interfaces, we issue the no shot command there, and then we issue the IP address config if IP add for G02 should come from the Office 3 here, the first usable. So that will be 48 dot, by the way, there's a space here after add. IP add space, then 48 dot 2 dot 3 dot first usable 193. Then followed by subnet mask 255 dot 255 dot 255 dot 224. Then okay, then press enter, then you type end, then you save, copy, run, copy space, run space, start. Okay, which means that you are copying what is in the RAM or running configuration and put it in the startup configuration or NVRAM. Then you just press enter twice, enter, enter, and you're done. Okay, so we have configured the PCs, we have configured the router. We are now ready to test connectivity, okay, among the computers. And when we do that, this is what we do. We go to PC1 here, open the command prompt, PC1, this will come out. You type ipconfig to check whether the IP address that we configured earlier is in the system of the PC. So you must be able to see IP add, subnet mask, and default gateway. Okay, when there is no problem with that, when the correct configuration or the IP address we issued earlier comes out, then we are ready to test connectivity. So we now issue the command ping space and type the address of PC2, which is this. This is the address we configured with PC2, and PC2 must come out with 4 replies. If in the first issuance of this command, the first line says request timeout, and the second and the third and the fourth lines are manifestation of replies, you just repeat this, and after that 4 replies will come out. To the same here, from PC1 you ping the IP address of PC3 here, and you must be receiving 4 replies. If in the first issuance there are only 3 replies, repeat the command, and the next is that you will be receiving 4 replies, which means then that the procedure that we undertake is correct. Okay, so if you I hope you were able to understand the procedure used in subnetting the a network using VLSM. Okay, thank you for watching. And